Okay, Nicholas Leifker here again, and welcome again to Management 409. I've decided to give a little overview of what you could find with regard to the littlefield simulation. Now, this is the trial version. So, this is effectively the copy, if you will, that you can access in order to get information. So, we log in, user, password user1, so click OK. And this is pretty much what you'll find. You have various parts of this particular simulation. You have the customer order queue, so customer orders that are coming in. And we can get some information here. First, plot job arrivals. And let's plot using HTML5. So you can get a plot of demand for our receivers. In other words, the jobs coming in. So, jobs per day. And we have information from day 1 to day 50. So, we could forecast this going forward, right? Because keep in mind what's going to happen from here on in. The way the data works is it's going to steadily increase at a linear rate from day 1 to day 120. The average will increase from day 1 to day 120. It'll still be bouncing around like that. We'll still have variation. But it'll steadily increase from day 1 to day 120. And then the average will level off from day 120 on to day 268, which is when the simulation ends. So, given this data here, from day 1 to day 50, how do you forecast to day 120? Keep in mind you have to forecast now to day 120. So think about what might work. Think about what might not work. After all, some forecasting methods only allow you to forecast for the next time period, if you will, day 51. Is that really what you want right now? No. What you want is something that will allow you to forecast long term. So I would recommend that you find something that will allow you to forecast long term. Okay? Also, it might be a good idea to use a forecasting method that allows you to get an idea as to what this variation is. Have some measurement of what this variation is. Because, well, there's some cases where we have things that are like standard deviations, but a statistician would cringe at the very concept of it being called a standard deviation. And the reason why is because statisticians, they distinguish between the standard deviation of a population and the standard deviation of a sample. To them, a standard deviation of a sample isn't a standard deviation, it's called something else. It's called a standard error. So, when we're dealing with forecasting, where have we seen a standard error? Okay. So, figure out what forecasting method will allow you to forecast long term, and will allow you to get a measurement of the standard error, and use that information to solve some of the problems going forward. Now, there are things that we can change. I'm not sure if we're allowed to yet. Apparently not yet. But also there will be buttons here and there that will occasionally, it'll allow you to purchase a machine. Those aren't turned on here for obvious reasons because in this case the simulation is designed to give students something to look at as opposed to something to make changes to, because all of the groups have to look at this. So this is station 1. This is the board stuffing step. So we plot utilization. Now keep in mind, these plots, you can download these and then use that information within Excel. So, this looks kind of interesting, doesn't it? It looks like there's a problem with this particular step. Utilization is 1. That could be a problem, couldn't it? That could be a big problem, couldn't it? What do you recall me saying about utilization as to what we wanted it to be? More to the point, with utilization, there's an equation that represents utilization, isn't there? If I recall, utilization is actual throughput rate over design throughput rate. So if we have utilization for this step here, and design throughput rate is what one machine can get done, well, and that's what we're trying to find, how much one machine can get done. Well, don't we need just the actual throughput rate to solve for that? I think so. So, we have the board stuffing step. We also have the testing step. Now, the testing step is kind of odd for reasons I'll explain in a few minutes, but we have the same options. We can plot the utilization for the testing step. Of course, download that information. But you'll note it's sort of leveled off here because, well, pretty much it's being starved by station 1, right? So we have an idea. We can get a fairly stable measurement, if you will, of the, pretty much of the designed, of the utilization for station 2. In station 3, the tuning step, we have, it's a little more bouncy, but you can still get a decent measurement with regard to utilization there. Just somewhere around here. Take an average, because you'll notice that it's not going up. It's just sort of there. By comparison, customer orders, this is going up, right? This is going up. So it's clear that we're being starved by station 1, right? Well, that also applies to the completed jobs. So there's several pieces of information here that are useful. Plot completed job count. And you'll note that it's sort of reached a plateau. Well, if it's reached a plateau, and this is what the process is actually getting done, well, let's see. Process is actually getting this done per day, completing this number of jobs per day. We have measurements of utilization for each of the 3 stations. We should be able to get an idea as to what the design throughput rate for one machine is at each step, right? Right? Right. Also, other things, lead times. This tells you how long it takes to complete a job, in days basically. And you'll note that it's gone up because, well, we basically have a backlog. Also, revenues. This tells us how much we're making per job. In this case, we're on the slow contract, so we're still making $750 per job. The reason for these zeros is because, well, nothing got done that day. So, we have some information. There is also a couple of other pieces of information that we need. And this represents the raw materials. This represents the circuit boards that we're putting in these satellite receivers. This is a process to upgrade satellite receivers. So this is the boards that go into the satellite receivers. And you'll note we have a lead time of 4 days, exactly 4 days. This sounds familiar, right? Right. So demand. If we have lead time, what's demand and standard deviation of demand? What's demand and standard deviation of demand? Okay, so we can also make some changes here once the simulation starts. There will be a button that will allow you to change the reorder point. There will be a button that will allow you to change the order quantity. And you'll note how the reorder point works. So you see, 60 kits go into each job. Okay? So this is basically 24 jobs. The order quantity, like I said, 60 kits go in each job. So this is 120 jobs. And you'll note it's $10 per kit, so it's basically $600 per job. So if it's $600 per job for the raw materials, and we have three options for the contract. We have a $750 contract, that's a slow contract, $1,000, which is a medium-sized contract, medium-speed contract, if you will, and then $1,250 for the fast contract. Well, don't we need to look at the profit that each of those possible contracts give us? Okay, so there's other pieces of information that we can access, such as the overall standing, because you can see where people stand with regard to this particular simulation. You can also get a history of the decisions that you've made. In this case, there have been no decisions. So it records basically what you've done. Okay? So my advice is to start here. Because, like I said, you have to forecast for future demand. Before you can make decisions about anything else, you have to forecast for future demand. So, start forecasting for future demand. Thank you.